Okay, so I'm going to break this review up into each section of types of questions I'm going to ask. So the first question that you're guaranteed to see on the test, probably two of them, one for proportions and one for sample means, is the sampling distribution question. So the idea with the sampling distribution question is that we know a lot of things about these particular variables. When we're taking a sample proportion, for instance, we know that if our sample size is big enough, and big enough for a sample proportion is NP and NQ being greater than or equal to 10, if that's true, then our sample proportions are going to follow a normal distribution. Just like we saw with the numbers in the binomial section, we talked about its approximate normality, and just like the means that we did in class with the dice rolling experiment. So if that's true, we have a mean and a standard deviation. And I do want to point out here, all this is available on our formula sheet. Nothing I wrote here in this little review is stuff we don't have. We're going to be using this. This is our part 6 part, the sampling distribution of a sample proportion. And you can see we have a mean and a standard deviation. And we're going to be using this part, right here, the mean and standard deviation of a sample mean. This is the part 7 part where we have a mean and a standard deviation again. Sample proportions, the best we can get out of a sample proportion is approximate normality because it's coming from a binomial. And binomials have a counted number, so we're never going to be able to get a purely continuous thing like we need for the normal distribution. And for sample means, we actually have two options. X bar can follow a normal. If the original distribution was normal, our sample means will still follow a normal distribution, truly normal. You do need to be told the word normal somewhere. And the other option is that we use the central limit theorem, kind of like we did in class, right? In class, we were seeing our distribution that started out flat, right, equally distributed, became more and more unimodal and symmetric when we were rolling those dice and taking a mean. And that does require that we have a certain sample size. So these questions, I usually do them in 2 steps, as I said. So first step, I'm going to ask you to identify or describe the sampling distribution. This is me trying to help, right? Here it says describe the sampling distribution of a sample mean. And I've even given you, okay, that means the mean, X bar, sample mean, follows. And then you need to decide. So let's go ahead and read the blurb up at the top, see what we were given. Okay. As TSU psychologists, we're interested in sleeping habits of college students. Suppose it is generally accepted that the average amount of sleep a college student gets on a typical evening is skewed left, that's important, with a mean of 7.10 and a standard deviation of 1.75. You'll note I used mu and sigma here. The reason I did that is because we do have some keywords telling us let's pretend this is the real thing, even though we know that's unrealistic, and says suppose it is generally accepted this is the real value. Nothing says it's from a sample, from a survey, or an estimate. Okay, and then we have some more here. Psychologists interviewed a random sample of 35 students, so now we have an N, and found that the sample mean of this sample, so the sample mean is 6.2. So we just got an X bar. Now here's where a lot of students get confused. Our sample mean doesn't have anything to do with the actual distribution of the sample means. This is exactly like what we saw in class with the dice, right? Every person had their own sample mean, but here what we're asking for in number 1 is to describe the distribution of everyone's sample means. So this one example is trash. It doesn't mean anything to us. And we can see that on our formula sheet as well. We need the mean and standard deviation to fill in this distribution, and they're right here. The mean of a sample mean is the real mean. The standard deviation of a sample mean is the original standard deviation divided by the square root of n. So we can come here and go, all right, well, I know some stuff now. Turns out, if I use my formula sheet, the mean is the real mean, which is 7.1. Standard deviation is the original standard deviation divided by the square root of n, which is 1.75 divided by the square root of 35. Okay, so we got our mean and our standard deviation. Now, if you remember, we had two options for the actual distribution. The distribution was either normal or approximately normal when it came to the sample mean. Since we were told this thing is skewed to the left, this was not normal to begin with. So the best we can do is get approximate normality using the central limit theorem. So since our n is big enough, it's bigger than 30, we have approximate normality. Our mean was 7.10. Our standard deviation, I'll go ahead and calculate that 1.75 divided by the square root of 35. Looks like 0.2958, keeping my 4 decimal places. If you cut those out, you're going to get in trouble with these other things and be off. Now remember, part 1 is supposed to be the help for the rest of the question. So we look at question 2 and it says find a probability. Okay, well, we're talking about an approximately normal distribution. So I know what this curve looks like. I know probabilities for normals and approximate normals are just areas under the curve. We know the mean is 7.10. And we know what we're interested in here is the mean, the average for the sample being more than 8 hours. So the fact that this says the average for the sample means, oh, hey, yeah, use this thing. We're talking about a sample mean. And we want to know when is it more than 8. And this is just a normal CDF question. Probabilities under the normal curve or normal CDF. The lower bound of the area we're interested in is the 8. We're going to go off forever and ever to infinity, or just a crap ton of 9s. And here's where another mistake happens. Don't go up here and use this mean and standard deviation. Use the two you calculated that are for sample means. These are for just one person. We want to look at a mean from a sample of 35 students being this. So we're going to put in our mean of 7.10 and then the standard deviation, which is the most common place students make mistakes on the test. There. And we'll just type that in our calculator and see what we get. Crap ton of 9s, 7.1. And you could do even the calculation in your for the standard deviation in your calculator as part of this. It'll do both. So 0.0012. So very unlikely that the average amount of sleep is more than 8 hours if we're looking at 35 students. Next thing it asks us in part 3 is what is our 80th percentile? So again, we know this is still all about part 1. This is all subsequent after part 1, and part 1 is supposed to help you. So we draw our little curve centered at 7.1. What is the 80th percentile for the mean amount of sleep in a sample that is such a sample of students would get? So we're still talking about sample means. So again, we are still using this thing. Now, we know we want the 80th percentile. We don't know what the amount of sleep is, but we know we want 80% on the left, right? 80th percentile is above 8% or more than 80%. So what's our calculator shortcut to do these inverse questions? Oh, inverse norm, right? Our left side probability is 0.8. Our mean is still 7.10. Our standard deviation is still that calculated standard deviation of 0.2958. That's it. 0.8, 7.1. This is 7.348, so I guess I need to round that up. And this is an actual value on this curve, so I do need units. And this was all about hours of sleep, right? So the 80th percentile would get about 7.3 hours of sleep from this sample. So hopefully that makes some sense. You're going to see this again and again on the sample exams. Like I said, part 1 is the most important part. The most common mistake is not using the standard deviation that you calculate in both of the subsequent calculations. That's the most common mistake. This can also come up in a sample proportion question, right? So we still have the same thing here. Sample proportion questions are a little easier to spot, that part 6 stuff. We read through here, it says, suppose it is known that 35% of students wear contact glasses. Well, it looks like we just got contact lenses. looks like we just got a proportion. And it's the true proportion because we have all these things. Suppose it is known. Nothing about a sample. This is the real deal proportion, or P. A random sample, okay, there's our N of 100 students is selected. Since we have a mean and an N and a P instead of a mean and a standard deviation, I already know where I'm going on the formula sheet because the other stuff means I need a mean and a standard deviation. But we keep going. It says fill in the blanks to correctly describe the distribution. Okay, again, we got some squiggly line crap. And it says of a sample proportion. So again, you're going to go to your formula sheet. I want you guys to get really used to just using this as your only resource because it's going to be helpful for the test. So sampling distribution of a sample proportion, we've got our mean and standard deviation right there. So I'm going to bring those two formulas back onto the screen over here. So the mean of a p hat of a sample proportion is the real proportion, and the standard deviation of a sample proportion is the real square root of the real probability of success times probability of failure all over n. And we have that. We have all that stuff from what we translated before. 0.35, square root, 0.35. Remember, Q is just 1 minus P still. All that. We'll just type that in over here. The sample proportion should all be around 0.35 with a spread or a standard deviation of, drumroll, 0.4770 when you round it properly. And then look what comes next. It's the same thing that we just saw in the sample mean question. What is the approximate probability? All right, we want a probability from a normal distribution. Let me draw the curve. We know our normal distribution is centered at 0.35 because we have this here. And we want the probability of being between 0.25 and 0.3. Now, one mistake you easily could have made is trying to set this thing up like we did in this question, right? Like we did up there with the inverse norm question. These probabilities or percentages here are p hats. They're proportions from the sample, right? They are our cutoffs. We want a probability, which is an area under the curve. This is not like the previous question where it said, find us a mean, right? We want this probability. And if we want an area under the curve or a probability from a normal distribution, we're still just doing normal CDF. Lower bound, upper bound, mean, standard deviation. And again, life is good. We're just going to make sure whatever we had there comes down. Mean and standard deviation. This is my help section, right? This is me trying to give you the help you need to get the question right. So if we calculate this in our calculator, we get 0.4, oh, I forgot a 0. Boo. 0.417. So a little slice of this guy. All right, I have one last question here. The other thing I like to do is talk to you about how these little curves change. I have that written here. How will the sample change our distribution? And the answers are really the same for means or proportions. For both means and proportions, the actual mean, if we're talking about a sample mean, is at the real mean. For the mean for a sample proportion is equal to real p. The n does not influence either of these. Both of their standard deviations are influenced by n, though. If you look at the standard deviations for both the sample mean and for our sample proportion, they both have a n in the denominator. So for both distributions, as you increase n, you're going to decrease the spread of your distribution or your standard deviation. And your central will stay in exactly the same spot because no n's here. That stays put. So this question says, okay, we want to talk about sample means, and we're going to increase the sample size. Well, if we increase our sample size, it's going to bring down our standard deviation. Mean will stay the same because it doesn't get influenced. There's your answer choice. So that's it. That's all we need to know about sampling distributions.